Hello guys, welcome to another tutorial session. Today's tutorial is going to be on sets. So we're going to dive into how we can understand Venn diagrams and also how we can answer some Venn diagram based questions. Right. But before we get into that question, please make sure if you're new to the channel, make sure to subscribe. Make sure to like and share the content with others. If you're a returning viewer, make sure to also like and share as we go along on this journey together. Alright, so we're given a universal set here that has sets X and Y with the letters U, V, W, and Z represents the number of elements in each subset. So we know that here V overlaps. That's the intersection between X and Y. And we have this Z, which are the elements that are outside of X and Y, right? So we know that the X intersection Y is going to be V. We know that X union Y, the complement of that is equals to Z. Let's change the color of the pen here. Alright, so can we use this information? So we know the number of elements of the inverse set is 150. So we know that n of the inverse equals to 150. We also know that the number of elements in X equals to 55. And the number of elements of Y is equals to 32. So we can use that information now. Alright, so let's answer the first question, which is, what is the smallest possible value of Z? Okay, so how do we get the smallest possible value of Z? That means we're going to say, in order for us to get that, the values of Y and X have to be at their maximum. And the maximum, we know that it's 55 and 32. But we know that in order for us to get the X union Y, if there are elements that are in both X and Y, they're going to reduce the total sum of the elements of X union Y. But if our V is close to 0 or 0, then it means that our union is just going to be 32 plus 55. That's the highest we can get, right? So we know that in order for X union Y to be its maximum, we need V to be 0. If V equals to 0, that means the X union Y is just going to be nx plus n of y, which is 55 plus 32. Therefore, Z, to get the maximum of Z, is going to be 150 minus 55 plus 32, which is going to be 63. So we've answered the first question. The maximum possible for Z is 63. Then the second question says the largest possible value of V, right? So we know that in order to get the largest value of V, so this is the second question. So for V to be maximum, we need W to be 0 or U to be equals to 0, right? So how do we get that? So let's get rid of some of this information so that we can dive deep into this one. Okay, so but we know that the value of X is 55 and the value of Y is equals to 32. If U is equals to 0, right, so if U equals to 0, let's go that one first. So if U equals to 0, that means V is equals to 55. But if V is equals to 55, that means the value of Y is greater than 32. So that solution is not going to work, right? So we know that that route is not going to work because we have that condition. So let's then look at when W equals to 0. So if W equals to 0, that means V is equals to 32. That means that it's still feasible for X to be 55, because if V equals to 32, we just need now U to be equals to 23. Right. So that part is feasible. So that tells us that the maximum value for V can be 32. So we have that solution is equals to 32. And let's look at the last part. So the value of W if U is equals to 45. Right, so what does that mean? If U equals to 45, and we know that the number of elements of X is equals to 55, therefore we can know the value of V is going to be 55 minus 45, which is equals to 10. So we have V is equals to 10. So we have V equals to 10, but we know that NY is equals to 32. If we go back here, this is equals to V plus W. Therefore, we know V equals to 10 plus W equals to 32, and therefore W is equals to 22. So W is equals to 22. So we can go back in here, and we now know that for C, W equals to 22. So that's how we solve this one. If you like the content, please make sure you like and you subscribe, and also share with others as well. Until another tutorial, goodbye for now.